A portion of Hawaii's famed Kilauea Volcano is more than 1,600 feet, yes, 1,600 feet higher than it was a mere 6 years ago. You might be pondering what exactly I'm referring to because if you look around, there aren't any new towering mountains on Hawaii's big island that didn't exist a few years ago. And you'd be right. What I am instead referring to is Kilauea's summit caldera, which lately has been filling at an absurdly fast rate. Whereas in May 2020, its crater bottom stood at an elevation of 518 meters or 1,699 feet above sea level, today on May 19, 2026, it stands at an elevation of 1,026 meters or 3,336 feet elevation, a 1,667-foot increase. Thus, you might be curious as to when this caldera will be infilled to the same volume it was before its major 2018 eruption in Caldera Collapse, so I'll get right to it. I expect that Kilauea's summit caldera will reach essentially the same level it was pre-May 2018, on or around December 30th, 2028. However, that is from one mathematical model, and if you take other trends, this figure could instead range from as close as December 12, 2027, or as far away as April 3, 2030. However, this assumes that Kilauea keeps erupting at a fairly constant or predictable rate and doesn't undergo a several-year-long period of absolutely no summit lava effusion occurring. If that were to happen, the date when it might be infilled would get further pushed back. However, lava will likely overtop the rim of the 2018 caldera to an extent before one of these days, since the caldera floor slopes downwards to the east. But why exactly did Kilauea's summit lose 1,640 feet in height in 2018? Simple. Starting on May 2, 2018, a vast quantity of molten rock in a magma chamber underlying the volcano's summit began draining away, heading more than 24 miles to the east before erupting at or near Leilani Estates. The eruption from 24 vents continued for multiple months, and in that time span blocks of Kilauea's summit caldera collapsed downwards to fill the empty space which had been created. This formed a brand new caldera within its broader summit caldera, marking a volume change of 836 million cubic meters of material. And yes, at least that volume of molten rock, if not greater, ended up being emplaced in Kilauea's East Rift Zone in 2018. After that eruption, Kilauea's summit caldera looked like this a year later in 2019. And now, here's the same caldera at the end of 2020. Now, mid-2021. 2022, 2023, 2024, 2025, and now, finally, 2026. Additionally, here's a two-dimensional cross-section view of the same timeline. So, exactly how much lava has Kilauea erupted in this time span, and how much has it risen since its episodic lava fountaining began? Well, since December 2020, Kilauea has erupted a grand total of 502.1 million cubic meters of lava, enough to hypothetically fill an Olympic-sized swimming pool more than 200,000 times. That translates to 60.06% of the lost volume of Kilauea's summit caldera in 2018 having been infilled in the time since. Also, since episodic hours-long periods of lava fountaining began December 23, 2024, Kilauea's caldera floor has risen by 97.2 meters or 318.9 feet. Here's a quick breakdown of how much lava has erupted at Kilauea's summit each year since 2019. By looking at Kilauea's so far 47 eruptive episodes of lava fountaining since December 23, 2024, I noted a downward trend which has notably slowed since eruptive activity began. I thus used this least regression power function to fairly accurately match the average lava fusion rate each second, and yes, this average includes the vast majority of the time when no lava was erupting, and extrapolated that to get the remaining volume needed to completely infill the remainder of the 836 million cubic meters lost at Kilauea's summit in 2018. If you are wondering, yes, this video is an update to a similar video I made almost exactly 1 year ago, which at the time forecasted a much broader range of dates between May 13th, 2027 and February 11th, 2033. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.